Hey everyone, you know those algebra word problems? The ones about tickets or coins or stamps that just kind of make your brain hurt? Well, if you've ever felt a little lost staring at one of those, you are in exactly the right place. Today, we're going to crack the code. We are going to build a simple, repeatable blueprint that will solve these problems every single time.
So here's the game plan. First, we'll get crystal clear on the difference between quantity and value. Then, I'm going to hand you the two-equation blueprint that is the key to everything. After that, we'll put it to the test with some real examples, I'll point out the common traps to sidestep, and finally, we'll see why this stuff actually matters way beyond your next test. Ready to jump in? Let's do it!
All right, so first things first, we got to nail down the most important idea here. And it all boils down to the difference between how many things you have and how much those things are actually worth. Just think of it like a little mystery inside your own wallet.
Let me ask you this. If you open your wallet and see 10 bills inside, how much money do you have? The answer is you have no idea, right? It could be 10 $1 bills, which is just 10 bucks. Or it could be 10 $100 bills, which is $1,000. The number of bills is not the same thing as their total worth. And that's really the heart of it. Quantity is just the head count of the items, the 10 physical pieces of paper. Value is what they're actually worth in dollars and cents. Now, the trick to solving these problems is that you have to keep track of both of these ideas at the same time. And that's where algebra comes in. It lets us do that with two separate equations.
So how do we actually do that? Well, we use what I call the two-equation blueprint. Seriously, think of this as your secret weapon, a skeleton key that unlocks every single one of these problems, whether it's about tickets, coins, you name it.
And you know what's so cool about this is just how simple it is. The first equation, the quantity equation, literally just counts the stuff. That's it. X plus Y equals the total number of items. The second one, the value equation, is where the money comes in. It takes each item, multiplies it by its price, and adds it all up to get the total cash. Every single problem is going to follow this exact structure.
And hey, here's a little pro tip to make solving these even quicker. If you take that super simple quantity equation and you multiply it by the negative of one of the prices, it sets you up perfectly to cancel out a variable using what's called the elimination method. Trust me, you're going to see how slick this is in just a second. All right, enough with the theory. Let's get our hands dirty and put this blueprint to work. We're going to walk through 3 different examples, starting with a basic ticket problem and working our way up to a real business scenario. Okay, here's our first one, a total classic, the school play problem. So, what do we have? We have 2 prices, 10 bucks and 5 bucks. We have a total count, 100 tickets, and we have a total value, $800. See? All the pieces are right there in the sentence. We just have to pull them out. So check out how the blueprint just eats this problem up. Step 1, we write our 2 equations. A plus S equals 100 for the quantity of tickets, and 10A plus 5S equals 800 for the value of the tickets. Step 2, we use that pro tip. Multiply the top equation by -5. Why? Because that creates a -5s, which will perfectly cancel out the positive 5s in the other equation. When we add them together, poof, the s terms vanish, we're left with one super simple equation. 5a equals 300. Solve for a, and there's our answer, 60 adults. Easy. Okay, let's level up. A coin jar. This time we have 20 coins, and they're worth $4.10. Now, the only new thing here is that our values, a dime and a quarter, are decimals, and that can look a little messy. So our first attempt at the value equation looks like this. It's technically correct, but, working with all those decimals can be a real pain, and it's easy to make a little slip-up. But don't worry, there is a fantastic trick for this. Here's the hack, and it's a game changer. Just multiply that entire value equation by 100. As long as you do it to every single piece on both sides, the equation stays perfectly balanced. But all those annoying decimals just disappear. And look what we get. Instead of working with dollars and messy decimals, we're now working with cents and these beautiful, clean, whole numbers. 10 cents for a dime, 25 for a quarter, and 410 cents total. It's the exact same problem, just way, way easier to solve. And from here on out, the steps are exactly the same as before. Our quantity equation is D plus Q equals 20. We hit that with a -10 to set up our cancellation. We add it to our new clean value equation. The D's vanish, we solve for Q and get 14 quarters. And then a quick plug-in tells us we must have 6 dimes. See, the blueprint holds up perfectly. All right, for our last example, let's look at how this whole idea applies directly to the world of business. The question is about something called a break-even point.
And all that really means is finding the exact moment when the total money you've spent, your cost, is perfectly equal to the total money you've brought in, your revenue.
So this time, instead of one quantity and one value equation, we really have two value equations, one for cost, one for revenue. And that break-even point is just where those two values are the same. So we set them equal to each other, we solve for x, and we get 33.33. But hold on, you can't sell a third of a shirt, right? So this is crucial, you have to round up. They need to sell 34 shirts to actually cover their costs and start making a profit.
So we've seen how the blueprint works like a charm. Now let's quickly go over the two most common traps people fall into, just so you know exactly what to watch out for.
The absolute biggest mistake is mixing up the equations. Look on the right, that's the correct quantity equation. It only counts the items. A plus S is 100. Simple. The version on the left is wrong because it's trying to cram prices, money, into the counting equation. Just remember this one simple rule. One equation for the count, one equation for the cash. Keep them separate.
And the second trap is something I like to call decimal drifting, and you see it all the time with coin problems. The mistake in the wrong example is that it's mixing units. It's using cents, 25 and 10, but the total is in dollars, 4.10. You have to be consistent. Either do the whole thing in dollars or do the whole thing in cents like we did with our hack. Just don't mix and match.
So we've got the blueprint, we know the pitfalls, but why does any of this actually matter? Well, because this isn't just a random algebra problem. This is a fundamental way of thinking that helps you understand the world.
And this is a perfect real-world example. This isn't theoretical stuff. Real businesses, like the coffee shop on your corner, use this exact same logic every single day. They track the quantity of cups they sold and the total value, their revenue, to figure out what's selling and what they need to buy for tomorrow. This is Business 101. So I'm going to leave you with this question to chew on. Once you start looking for this pattern, I promise you will see it everywhere. What else in your world has both a quantity, a certain number of things, and a value that's attached to them? Think about it. Thanks so much for watching.